Function in other languages. Here is how function looks like in JavaScript and Go. So in Python, we know that it starts with the def keyword, then function name, followed by arguments, and below which you'll have a function call, right? Then it comes to JavaScript. So here we don't use indentation, but we use curly braces. Both JavaScript and Go language uses curly braces. So same, instead of there we had a def keyword, and here it is a function keyword, function name, and list of arguments, and body of the function. Then below we'll have a function call somewhere. Go programming language, here it is not function, it is func. That's a keyword we use, followed by argument. Here you know that in Go language every variable must come with data type. If you say variable 1, then you'll have to mention which type of data it is, int or float, whatever it is. Then you'll have set of instructions within the function, then you'll have function call. In Go, return data type must be specified in case return statement is used, right? In other languages you don't have to do that, but only in Go programming language we'll have to use data type in the return statement. Anything enclosed in the square bracket is optional. You may use square bracket or you may skip using it. JavaScript function given below is returned to allocate hotel room based on the travel class. Tryout and observe the result. So allocate hotel is the function name, right? And it takes two parameters: business, that is a travel class, Tom, name of the person, name of the traveler. If travel class equal to business, then you say has been so and so person allocated a suite room. If it is economy, then the so and so person is allocated a deluxe room. Otherwise, we take only two classes now, business and economy. Let's run this. So Tom is from a business class, so he's allocated a suite. So if the same is economy, then Tom has been allocated deluxe room. Let's try the same example on Go language. Same allocate hotel. Now we store it when we take two parameters and store it in a variable. So this is syntax in Go language. We'll have to use a var keyword, name of the variable, then data type. Then finally you will assign values. So we pass these two parameters, and it is also important to mention the data type in the function definition while you receive it in the formal parameters section. So you check, the rest of things are almost same. So this is the output of this program. Which among the following statements are correct with respect to functions? It is a section of program that performs a specific task. Yes. It helps to clearly separate tasks within a program. Yes. Control can be transferred back and forth between different functions based on need. True. It helps to achieve modularity. Very much. It supports reusability. Yes. All the five are true. Match the following based on collect tax function given below. Def collect tax of x comma y, then it should be a function signature, function definition, or you can say the signature. Collect tax of a comma b, it is a function call. A comma b, so this is where we pass, so this is actual argument. X comma y, so whatever value we pass here, that is being copied to xy, so then it is formal argument. This is it. Choose the most appropriate function call needed at line number 4 to get the output as result 4. So we should get result 4. So what is which line we should place it here? That's the question here. So if you take the first one, if you pass, we'll consider two examples. So if you pass Infosys comma 3, then what happens? If you pass it here Infosys comma 3, then in the message we'll have Infosys num is 3. So message is the new variable we are creating, and we are performing slicing. What will happen? If you do not mention the start index, by default it is taken as 0. Num value is 3, we know, right? If this is going to be the value, then what happens? 0 to 3. Infosys 0, 1, 2. So it takes up to 2. So result, it takes first 3 letters, but we'll have to return the length of the message. So it has to give us result as a 4. So now in this example, if you consider this value, we'll take only result as a 3 but not 4. But if you take this as an example, we will get the right answer. I want you to evaluate, try all these function call, pass the values and check the result. Predict the output of the following code snippet. It's very easy. So look at this. The flow starts from here, right? Function 3. Inside function 3 is executed. Then we call function 2, right? Then it goes up. Then what happens? Inside function 2 is executed. Then it goes to function 1. So function 1 inside function 3. So function 3, function 2, function 1. Function 3, function 2, function 1. So it should be from these two outputs. So we'll have to check whether it is going to be 50 or 10. Then what happens? 10 is returned. So here it comes. Then it is written, it is stored in num. Then num is written. So it comes here. Now num will have 10. Num is equal to 10 into 5. It becomes 50. Return num. 50 is returned. So this must be the output. Yes. This is how it works. What is the output of the following code snippet? So the program flow starts from line number 17, display. So we pass 1000 and 3500. So it comes here, argument 1000, argument 2 is 3500. If verify of argument 1 comma argument 2 equal to argument 1. So we call up this function or verify. Then it comes here, 1000 and 3500 are substituted here. If num1 greater than num2, 1000 greater than 3500, no. Else if num1 equal to no, then what happens? It comes to return part. So it returns num2. Num2 is 3500. So 3500 equal to 1000. No, it comes to this part. Verify of elif part, it comes in argument 1 comma argument 2, right? We know that verify of argument 1 comma argument 2 returns 3500. So this is not right. Then so elif false also, elif section will not get executed. Then by default it comes to else part. So B should be the result. Yes. Write a Python program that converts temperature in Celsius to Fahrenheit and vice versa. Implement the requirements using function. So hint. So to find out Celsius, so it is Fahrenheit minus 32 into 5 bar 90. Goal of this tryout is to create a function from scratch and invoke it for the given problem. So let's take two methods, Celsius to Fahrenheit and Fahrenheit to Celsius. So to find out if Celsius is given, to find out Fahrenheit, so the formula for finding out Fahrenheit is Celsius into 9 bar 5. It was, for Celsius it was 5 bar 9. It is 9 bar 5 plus 32. There it is minus 32. So if you simply evaluate this expression from left to right, if you send 5 bar 9 to this direction, so what happens? It comes 9 by 5 into 9 by 5. Then f minus 32 is so and so. So f is equal to c into 9 bar 5 plus 32. It's very simple. Now we need to invoke, pass the parameter and invoke. So now let's invoke the first method, Celsius to Fahrenheit. If the temperature given is in Celsius, and we'll have to invoke this method, Celsius to Fahrenheit, to convert to Fahrenheit. When this method is invoked, Celsius to Fahrenheit, the value which will say 1 degree Celsius. If we want to know the equivalent Fahrenheit, then we pass it through this method, Celsius to Fahrenheit of C. It comes here, the value is substituted, C into 1 into 9 by 5 plus 32. It returns the value. It returns the value as 33.8. Then again, see this percentage dot 2f. It displays 2 digits after the decimal point. 1 is the value, so it displays 1.00. If you put 3 here, so it takes 3 digits after the decimal value. The same thing is here, using 0 before or after, it makes no difference. Alright, if you put a 3, then what happens? So 1 Celsius is 33.800 Fahrenheit, right? 1, so you say this F takes value of the C. So C value is, we know that 1. Since we have said we need to have 3 decimals after 1, so it has taken three zeros. It has added 3 zeros, 1.000. So 1 Celsius is 33.8 Fahrenheit. If we take 1 Fahrenheit is minus 17.22 Celsius. That's about it.